Okay. So you have this question. You say, write a function called lucky7. The function has an integer parameter that is positive. It calculates an answer by turning the first 7, and when they say first 7, they mean from the left, to the parameter 77. Okay? And then only one 7 gets duplicated. There's no 7 in the if there's no 7 in the parameter, the answer is a copy of the parameter. Can we see that in the third one? 1, 2, 3, 4. All right. Let's do that. So they tell us it has to be a positive parameter. So first we write the title line. We return an integer, lucky7, and we take in an integer. Okay. So they say positive parameter. So if it's not, do they say what to do? If the parameter is not positive, your function can return any convenient answer of your choice. Okay, so we can do whatever we want. If x is less than or equal to 0, we'll just terminate the program. Okay. If not, then what we want to do is we want to hold a variable. We want to say something like y. So int y will hold this variable that keeps on getting rid of the last number. So 7. We want to be able to get to the last number. So we want a variable that'll get rid of all of these. And to do so, we say lucky 7 of x divided by 10. Divided by 10 gets rid of the last digit. And then we say two things. We say if x would equal, sorry, if y, not x, if y equals x divided by 10, and the last digit, which is x mod 10, is a 7, put these also in parentheses, then we return. So we want to do two things. We want to make two spaces because we're returning 77 now. So we return 100 times y, right? That'll mean whatever y is. Say y is 5. Say y is 5. We put two spaces. That's 177, and the 7 was here. It got duplicated, and then we add 77. If it's not though, if it's not the first 7 we got to, then we say return 10 times y plus the last digit that we held, right? Essentially returning same number. Now let's go through this one together. Say we'll put in 747, say lucky 7 of 747, okay? That's our parameter. So we check this one. Is it less than 0? No, so we go to the next line. Passes this one, let's do the next line. Y, let's take a look. Y equals lucky 7 of 74. Okay, so we go to lucky 7 now, but this time we do it of 74. And then we check. It still passes this one. And we go to y again for this one. Y equals lucky 7 of 7. Okay, so we go to lucky 7 of 7. And then it passes this one. And we see, okay, we do y equals lucky 7 of 0. And now this is our base case already. That's our base case. When x is 0, we return 0. Okay. So now we look at this one, right? Because that's how recursion works. You break it down going downwards, and then you solve plugging back up. Let me make sure there are no questions. Okay, good. And yeah, if you guys can fill out the attendance form, that would also be really great. Okay. So we plug this back in, 7, and now we continue from where we left off. We check this one. Sorry, for the orange one, we checked here. We did lucky 7. Now we check this. We say if y, which is 7 in this case, right? Where's y? Y equals x divided by, sorry, this whole thing is y. If that whole thing equals x divided by 10, which it does, and x mod 10, this is my x, 7 mod 10 is still 7, so both of these are true. We return 100 times y, which is 0 in this case. 0 in this case, yes. Y, this whole thing gave us 0. That's how we know. And then x divided by 10, right? This is 7 divided by 10 is 0. And this whole thing is 0. Then we return 100 times y, which is 0, plus 77, which is just 77. This whole thing is what we return from where it was called. So it was called from lucky 7. So then we check this one. This one is going to be false for the if statement. So we go that pretend like there's an imaginary else here. Return, and we say 10 times y, which in this case y was 77, because that's what gets plugged into that y, plus x mod 10, which is 4. So 774. Now this whole thing is what gets plugged in for this y. And so when we look at this, we return 10 times 774 plus the 7 over here. 7740 plus 7. Okay. Does anybody have any questions about this? Okay, I'm gonna assume it was understood unless somebody has a question. Okay, we can move on to command lines. Does anybody have a particular question they want to go over command lines, or should I just find one myself? Okay, so let's do it. So if I tell you compiled to and executed with the command slash So now, my argv is an array that holds the arguments, okay? My argc is the capacity. It tells me how many arguments. And this holds the okay. So how many arguments do I have here? Somebody write it in the chat. So there would be 3 arguments here. Okay. And argv would hold the arguments in that array. It holds dot a dot out, abc, abc, and abc 1, 2, 3. Now again, just like in any array, we hold that this is the first position, this is the 0 position, this first position, and the second position. So if I say C out arg of argv of 2, you would say it equals ABC 1, 2, 3, like that. Okay. Now let's add in this string words of 4 equals, and I'm pulling this out of one of the old review questions, a very easy question. Okay. Now we use the substring method. Words sub 1 dot you know what, we're not gonna do word sub 1, we're gonna do word sub 3 dot substring of 4. Okay. Who can tell me what this one will print out? Does anybody know what this would print out? So we break it down. This is going to be 0, 1, 2, 3. So this right here, question, is word sub 3. Now what we do is we break down question, because strings are essentially arrays of characters. We break it down, we say 0, 1, 2, 3, 4, 5, 6, 7. So if I say substring 4 and words to 3. So we'll say question dot substring of 4. I start at the 4th position and I go all the way to the end. So this one would print out TION. Any questions about that so far? Okay. So then let's use a for loop. We're going to say for int I equals 0. I is less than or equal to 2. And plus plus, we're going to see out words sub I. So now that we have a loop going on, with words, so this right here, we start at words 0, 0. And so what we do is we break down A is 0, and A only has one character, so 0. So that's A. I becomes 1, so it's 1, 1. And so we go to 1, and we break it down, 0, 1, 2, 3. And here's the 1, E. And so words of 2, 2. Here's 2. Go to position 2 again. That's S. So your final answer for this would be capital A, lowercase e, S. Sometimes the teachers are a bit more particular with the capital. So if you put a lowercase a, they would say that's wrong, and they might give you half credit for it instead of full credit. Okay. Any questions about this one? I'll give you guys a minute just to look it over. The recording will be available whenever the Learning Commons is able to upload it. I think it should be by the latest Monday morning, but if they're able to upload it a little bit earlier, like later tonight, once the meeting ends, I'll be able to send it over to the Learning Commons, and they'll be able to just upload it to the website. This is the website. Yeah, I don't know if they're going to be able to tonight because it is the weekend. I think they stopped working at 5, but give me 1 second. Let me see if I can. Yeah, this is exactly where it would be. Right under resources for computer science, and it's split into 3 classes, 111, 211, and 212. Okay. Anybody have any other questions? If not, I'm going to move on to the next question. Let me see what you guys have on your final, actually.
hold on. So for loops, you always have to include the I brackets, right? The two I brackets.
Yeah, if you want to iterate through a loop, you have to have this I over here, or any variable really. It doesn't have to be I, it's J, but then you also have to, since we're iterating through words, and words is an array, I declared it as an array up here of size 4, you have to have those brackets with it.
Okay, thank you.
No problem. Okay. Um, okay. Let me see what else is on your. Okay, so I see you guys have title lines. You have, what else is there? Output questions. Recursion. Command lines. And writing functions. Okay. Tell me if I missed anything. If not, we can go ahead and look at some of the functions. Do you guys hear me now? Okay, perfect. Okay, let me reshare my screen. Okay, you guys can hear me now, right? Just making sure one more time. Okay, great, thank you. All right, let me repeat what I said here. So A takes in two parameters. It has two characters, so char A, char B, and whatever it has to return has to be compatible with whatever CH is, right? Because in C++, you can only put types that are together with each other. So whatever this one returns has to be a character. B, let's do B together. So B takes in how many parameters? Takes in two parameters, right? The first parameter is num0, where numbers is integers, so it's going to be int a. The second parameter is a char, so char b. Okay. What does it return? It has to return something that can go into RL0. RL0 is a double, so it returns a double. Okay, let's try C together. C takes in how many parameters this time? C takes in one parameter. It takes in whatever A returns. And we know that A returns a character. So C only takes in a character. We actually probably shouldn't call it C, just because that's the name of the function. So then this one should not be A. So A will say C. And here instead of B, we'll say C. Okay. Now, this returns something that can be placed in num sub 2, which is an integer. Okay. So far, so good, or does anybody have any questions? Okay. So D takes in two parameters. We're going to look at this inner D first, because it's much, much, much simpler. It takes in two parameters, char A and int B, right? We can say that. The question is, what does it return? So this small d, whatever it returns, will be the parameter, the first parameter for this bigger D right here. I'll put it in orange actually. Whatever that small one returns will be put into the big one. So we know, and it's going to be as the first parameter. So we know it has to be a char. Because if this whole thing returns anything else than a char, that wouldn't be good because the first parameter of D has to be a char. Has to be a char. Okay. Let's look at E now. Can we do function design? Like, yeah, we'll write a function, sure. We're doing now one for E. Okay, E takes in two parameters. This is E. Parameters are separated by commas. So E takes in two parameters. It takes in, so this is an integer, and this is a double. An integer plus a double is a double. And then this RL is an array, a double array. So we have to write it as such. Question is, what does it return? So it is the first parameter for A. This whole thing is the first parameter for A. And A's first parameter is a char. So this whole thing has to return a char. Okay, does anybody have any questions before we move on to writing functions? Okay, let's go ahead and write some functions. I'll just find a question. Okay. Let's see. Okay, we can do this one. Number 11. Okay, let's do it. So this one is called adjust. It just adds a random integer between -2 and 2 to each element of an array of integers. The biggest allowed change to an entry of the array is 2. Okay, so we can only move it up or down 2, and the smallest is change 0, right? There's no change. So we want to do a random number. So does anybody remember how the random number generator works, meaning the formula for it. And so the formula for this is, oh, whoops. Let me find something else. Rand mod max minus min plus 1 minus min. It's like this whole thing minus the min. Okay. So in this case, it would be the maximum we said was 2, the minimum was 2. So mod, so 2 minus 2 is 0, that's 1. Minus the minimum is 2, it can go, right? Yeah. Wait, no, max. Max plus 1 plus the minimum, I think, should it be? Is that correct? Max minus the min plus 1. Let me take a look at my notes. Yeah, max minus min plus 1 plus the minimum. Okay. So we also have to do, they say use the appropriate hashtag include statement. So hashtag include CSTD library and hashtag include CTime, right? That'll make sure we get a completely new random number every time. So we'll say srand time of 0 after we include both of these, obviously. And we can say int r equals rand mod max is 2 min, so 1 plus 2 this should be a negative, sorry. It's 5 plus 2, so this should be 5. Okay. Now we want to adjust each one in the for loop. How do you want? Yeah, every entry in the array. So we do that by saying I is less than the array's capacity. So we'll say C plus plus. And so this one we just say A sub I would equal that plus R. And then that's it. And then just our title line, void adjust. And we see from adjust, it takes in the array X, that's 1D, and the capacity C. Okay. Does anybody have any questions about this? This should be a minus here.
Can you sorry, wait. Can you go over this again? Like just to explain.
Which portion do you want me to explain?
Like why are we using void for this one?
So up here in the main function, I'm going to put a star next to it. There's no C out over here. If there's no C out, then you automatically use void.
Okay.
So we use a void over here because what we end up doing is just changing the values. Because remember, arrays are always passed by reference.
Okay. And so when it says like the biggest allowed change to the entry of the array is to either up or down, right? But you just like for the for loop, you just like increase it like by putting I plus plus.
Correct. That's how you increase in the for loop. Yes.
Yeah. Okay. Oh, so we can either choose to like put I plus plus or I minus minus, right?
You could put I minus minus in a for loop, but in this case, if you put I minus minus, then you would have to start I at C and say I is greater than, or no, sorry, you'd have to start I at C minus 1, and then I is greater than or equal to 0, I minus minus.
Okay. Got it. Thank you.
No problem. Anybody else have any other questions? Okay. Do you guys want to do another recursion, another program design question like this where we write functions, outputs, title lines, command lines?
We don't have title lines. If it's like from Professor Aquilar, he said
Oh, you
he
guys don't have title lines on your
yeah,
final?
no.
Okay.
So we have like function design, output, like the command lines, and recursion. Wait, what do we have? Like, just gonna say what we have so that we can yeah, maybe we can like we can do like the most points is for the writing function.
Writing functions.
Yeah, so it's like 20 points for this one. And then recursion.
Okay, we can do more functions if you guys want to. Let's do it.
Yeah, that would be helpful if everyone, don't mind. Or if they have anything else they need help with, I'm fine as well.
Let's do it then. Okay, let me just find another function here. Okay, we can do this one. It's called advance. Let's take a look at it. So for advance, we have to move each entry one place forward in an array and move the last entry to the beginning. Okay. fine. So essentially this is what we're doing. If you have the array 5, 1, 2, you advance it 2, 5, 1. Like that. Each one moves 1 to the right. Forward, essentially. They call it forward, but it's to the right. Yep. Okay, and they give you the example here. 3, 1, 4, 1, 5. You see everything moved 1 forward. This moved forward, this moved forward, this moved forward, this moved forward. And you get 5, 3, 1, 4, 1. Okay. So we're gonna write there's no C out here, so it's just a void. Advance, and it takes in the int array X and the capacity in C. Okay. So we definitely want to have a variable to hold the last one, because that's what we're going to attach to the first one, essentially. So we're going to say int temp will equal x sub c minus 1. Okay, we can't say c because arrays start at 0 and go up until the capacity minus 1. So that's what we have to do here. Somebody wrote in the chat something. Okay. Yeah, Mohammed, you were right. We could do a rand mod 5 minus 2. Sorry, I was just seeing that now. Okay, once we have that temporary variable, so say we have 3, 1, 4, 1, 5. We stored the 5 somewhere. So now we can shift everything over. We can use a for loop for that. Oh, we should probably start this one at the end. We start this one at the end. For int I equals c minus 1, I is greater than 0, I minus minus. And essentially what we do here is we just say a sub I, where I is either 4 or 3 or 2 or 1 or 0, wherever it may be, is now going to equal a sub I minus 1. Yes. So that means 3 will equal whatever's in 2. 2 will equal whatever's in 1. 1 will equal whatever's in 0. And so if this was 0, 1, 2, 3, 4, this is now what happened. We shifted it over 1. And then we saved the last one, though. We saved the 5 because we knew we were going to shift over into 5's place. And so outside of the for loop, we say a sub 0 equals temp. And that's it. Any questions about this example? Okay. Great. If there are no questions, do you guys just want to keep doing program designs for the next 30 minutes, or do you guys have a preference of doing something else?
What's string function?
Sorry, can you say that one more time?
What is like a string function?
Where we return a string function, or
No, because I didn't go over the function, so he said like there's going to be like string functions. So I was thinking, is it like to write the function for the string?
That could be. I'm not sure what he meant. Does anybody know what Professor Akinlar meant when he said string functions are going to be on your test? Oh. I see. Okay. String functions are this is string functions. So it's dot substring, dot find, dot rfind. There's dot insert, dot replace. I don't know which ones he taught you guys yet. Command line. Let me see what else. Dot insert, dot replace, rfind. There's dot erase also. But if I remember correctly, these three are the ones you'll find the most. What about files?
So can we do an example?
This one?
For the picture. Yeah, for the like substring.
Yeah. So if I give you and I say dog, okay, I give you this array of strings. And I say a sub 2 dot substring 3. What would be printed out here? I'm not sure what files is in 4. He might have mentioned it in class. That's probably why I was in her picture. So what would be printed out? I think we did a similar example like this before. So remember, the substring gives us a portion of the bigger string, of the full whole string. And so a sub 2 is which element here? Let me see, Fant. Excellent, Fant. Yes, good, Mohammed. Nice. Fant. We go to a sub 2, which is elephant. We do the substring, so we break it down 0, 1, 2, 3, 4, 5, 6, 7. And we start from 3 going to the rest of the word. Sometimes they will give you a second parameter. They can say this means start at 3 and the length is 2. So if it was this, it would just be PH because that's a length of 2.
Got it.
Okay. Now you can do find and rfind. Rfind, the R means find it from the right, and find is just like how we read in English, from left to right. So if I tell you what would my answer be? For A sub 4 dot find H.
So A4 is horse, right? Like, sorry, monkey, right?
A4 is not monkey.
I can see, like, I only can see, like, the.
Sorry.
Oh, okay. 0, 1, 2. Okay, so it's okay. So that's like horse.
Correct.
So,
It's horse.
and then H is 0 though.
Exactly. So what would be printed out in this case?
0.
Perfect. Good job. Yeah, Mohammed, you also got it. Okay. Excellent. 0. Okay, we print out the index that it has. So let me see if I can find another example, but this time we use command lines. Do you guys have code output questions also? Let me see what. Just what does he mean by pattern questions? Was it like the stars that you have to draw?
Yeah, but that's very difficult because my lab professor, he said, like, just focus on the other problems because pattern is going to be very confusing.
The files, I think he means O stream, in stream, or just regular stream if you guys haven't gotten to O stream and I stream yet. I'm trying to think what else there would be.
I think we're just doing the regular stream. Yeah, because and we are also like he also went over a string as function parameter.
Let me see. Okay. I don't remember doing. Oh, you don't remember doing anything with files? Okay. I'm not sure. I would email him about that because I don't know what you guys learn in class. But let's see. I wanted to do another function question.
Could you do question 40 after this one?
I can do question 40 now.
Okay. Yeah, because it's like it's kind of confusing to me for that one.
Let me see question 40. This is 30. 40. Are you talking about this one? Sum ratios?
No, I think I'll try to find it. I'll look through the PDF and try to find which one.
Yeah,
it
if you
is.
can send a picture of it, I can do it
Yeah.
as well.
Thank you.
The files like reading and outputting on files. If you don't remember it and other kids say they did it, it could be that you missed a class and you just need to catch up on it. It's better to know now than to be surprised on the final. Okay, let's do it. Okay, we can still do this one, sum ratios. So you have a function called sum ratios. The function has two integer parameters that are positive and have the same number of digits, all of which are non-zero. It prints the sum of the ratios of corresponding digits. For instance, sum ratios 1, 3, 2, 5, 6, 8 calculates 1/5 plus 3/6 plus 2/8. and returns the answer of 0.95. If the parameter has an illegal value, your function can operate however you choose. Okay. Functions more than 8 lines of code will lose points. Okay. So essentially they say if we can return the double, right? We can return an integer, but it's better to be safe and say we can return a double. And then some ratios takes in 2 integers. Okay. If it equals 0, right, if one of them equals 0, then just return 0, I guess. It's not, can choose it however you want. But if not, then what you want to do is you want to return the sum of their ratios, right? The sum of the first one divided by the second one. So we're going to say return x mod 10 divided by y mod 10, and x should probably be and this should be typecasted, right? Because we don't want to do integer division. Yes. And then we're going to do the same thing for the rest of the digits. Okay. So this again takes the last digits. In this case, it's 2 and 8. And we do 2 divided by 8. And instead of getting 0, we get a decimal now because we typecasted it as a double. And then we do this, and then we get rid of them. And we do the same thing with 3 and 6. And we add that to whatever it is. And then 1 and 5. And add that to whatever the total is. Where the file lectures we learned are from lecture. I think Tasneem put it in the chat. But yeah. So this code is the recursive code for sum ratios. Does anybody have any questions about it?
No, I think it was pretty simple.
Okay. Perfect. Was
So
somebody able to find question 40 they were looking for?
Yeah, could you do question 58?
On this packet? Let me see if it's the same one. 58. This one?
I think it's a different packet that we're using.
Let me see. Are you using the final packet instead?
Yeah.
Let me take a look. Give me one sec. 58. Uh, 58 says 19 equals square root of 361.
Yeah, that one.
Okay, no problem. So let me take a screenshot of this and send it to myself so I can upload it. Okay. I just put the problem in the chat. so everybody can see what we're talking about. So just so I'll read it just again. Okay, 58. It generates random numbers between 1 and 1000. As soon as it generates a number that is the square root of the number right before it, it should print out these numbers, report the total number of random numbers that have been generated, and end. Okay, let's take a look at it then. Make sure the chat is open. Okay, so random value should be computed with C++ function rand. Okay, so we are able to generate random numbers between 1 and 1000. So we'll say our basic include stream C time hashtag include cstdlib and using namespace std. I don't know if they'll make you do all of this on the exam or just well, this one says write a complete program, so you would have to. If it just says write the function, then you can just write the function. Okay, so we go to our int main, and now we want to have a variable that just holds the random number. So we say int, and I call it r, is a rand of 1000, right? Rand max minus min plus 1 plus the minimum. And then they want to tell us how many numbers we generated, so we should have a count. And we set it equal to 1 because it's automatically going to be our first count. Okay. And then let's see. Okay, oh, so now we have to have a while loop. We can't use a for loop because we don't know how many iterations we have. We have to use a while loop, okay? And we'll say while true, just means we stay inside the while loop. And we create another random variable. Same as r, we can say int x equals another random variable. The reason why we can't say r is because then the two numbers will be equal to each other. Okay, so now let's do count plus plus. This is a second random number that was generated, right? This was the first random number. This is the second. And count changes. So then we say this. We say if x is equal to r, sorry, I want to find the square root. So if x times x equals r, we print out whatever they wanted us to print out before. And we say cout x equals the square root of r, right? Because both x times x had to equal r, which means that r has to be the square of x. And we close that off. And then we say how many numbers were generated. So generated and then we return 0. That's if they equal each other after the multiplication. If it doesn't, then we want to create a new random variable. Yes, we want to create a new random variable for x, and we let r equal the old random variable. Okay, we kind of want it to do successively. So if we say the first one is 1, the second one is 2, this becomes 2, and this can become 4. This becomes 4, and this might become 4 again. We don't know. That's the thing, okay? That's the only difference here. And then we end the entire program. Any questions about this? I know it was a lot, so I'll leave it here for a second for you guys to take a look at it.
Could you explain why we use a while loop instead of a for loop again?
Yeah. So a for loop has a definite stop, right? We say int I equals something so long as I is less than a specific number. But in this case, the question never tells us specifically how many times I have to loop, right? It doesn't tell me if I have to loop C times, X times, Y times, 5 times, 10 times. So I just need to have a while loop. While just means so long as this is true. If it's not true, then I don't continue anymore. And the only way it wouldn't be true is if I return 0 over here, which means that I was able to solve everything I needed. Does that make sense?
Yeah, that makes sense. Thank you.
Okay. Right. Let me also just put something in the chat for you guys. All right. Do you guys have any other questions for me?
Can we do output questions?
According to the picture that I think you sent it, there isn't going to be output questions in here.
Like command lines.
Yeah, we did command lines.
Sorry, what did you say?
Yes, we were able to do command lines before. I think I actually still have the notes up here. Should.
Do we have like 40 minutes? Like for this review session?
Yeah, if you guys still have questions, we can stay until 5:30. Where is? Give me 1 sec. I know I did it up here somewhere. Yeah, I had the command lines here before. No, this isn't it. Yeah, we did command lines though. Give me 1 second. Yeah, we can do one of those too. Sure. Okay. Do you guys want to do patterns or do you guys want to do command lines? Patterns? Okay. And so, okay, so let's do a pattern. That's the nested for loops. So let's start with something simple. Say I give you this pattern. Okay, say I give you this pattern, but it should work any number of rows and columns. So what we do is this. Look at the pattern here. What do you see? Alternating rows. Rows alternate between X's and O's, right?
Sorry, did you ask a question?
Yeah, do you see the pattern here, or how I phrase the pattern of alternating rows between X and 0? X and O.
Yes.
Okay, how do I phrase it?
Okay, so we have like 5 rows and 4 columns.
Good, but I mean in code, how do I phrase that these rows alternate between X and O?
So is it like for I equal to 0, then I is less than or equal to R? Something like that. Sorry, I'm not good at nested loop.
So remember, these are sort of like arrays, right?
Uh-huh.
And they start at 0, 1, 2, 3. So every even row every even row is X. Every odd row is O. And so that's very simple to say in code. We first do the for loops. And then we'll say R is the number of rows. And C is the number of columns. And then we say if, let's call this, we'll call this, what do we want to say? If R mod 2 equals 0, this means if it's even. Then we see out an X. Else, we see out, if it's not even, then it has to be odd. See out an O. And we see out an endo. And this would be how you do the pattern question if this was the pattern up here.
Can we do one recursion?
One what? Sorry?
Can you go over like recursion recursion problems?
Yeah, we did recursion. Do you guys want to do some more?
Yeah. I did not. I think I was not here then.
So let's see if I can find one really quickly. Let me scroll all the way down. See if there's... Okay, we can do this one. 2 number. Okay. So we have this specific function. It's called 2 number. It uses an array of integers, each entry of which is between 0 and 9. So we can't have 2-digit ones. And returns an integer form by using the entries as its digits. Okay. So here's an example. 3.314159 just stays the same. And then 2 number, if we add 1, then it's 314160. See, we take and we really just add a 1. Okay. Okay, so let's do it together then. So first, what does this return? What's the return type for this?
Int.
Excellent, an integer. It's called 2 number. Takes in 2 parameters, right? The first one being an array. Second one being the capacity, we'll say C. And then we want to say if so the most it can be is 9. If, so we want to say if the capacity is less than or equal to 1. Does somebody have a question? If the capacity is less than or equal to 1, we just return the first position because there's nothing for us to really do. But if it's not, we can just return. And now here we have to do a lot of shifts because we're technically adding. So we want to create 1 space at least. So that's multiplied by 10. So we have to do 10 times, and we have to do the recursive call, 2 number, where we pass in the same array A. But this time the capacity is 1 less. And then with that extra space that we have, with the capacity that's 1 left, we put A sub C minus 1. Put the capacities. Okay, does that make sense?
So, why did you put a 0 bracket?
For if C is less than or equal to 1.
Oh, you can, but it says like you can return any answer of which
Yeah,
which
so you can put return 0, you can put return -1, whatever you choose to
Okay.
put.
Okay. And then return 10 times to number. So why we're using product here?
Why are we using what?
Like, why did you put like 10 times to number?
Because we want to have an empty space at all times.
Mhm.
So at least at one point. So here's an example. When we add these two numbers, we know it's 0, but we want to put an empty space just because that's how that works in computer science, because we're not sure if this will be really, oh, whoops. If this will be a 6 over here, which means that eventually we'll need to have that empty space, because if I add a big enough number, that turns this into 4, 0, 0, 0, 0, 0, 1, something along those lines.
Mm.
For example, if this was in my array and I added 1 and I didn't have that extra space, this would be 0, 0, 0, 0, 0, and then I wouldn't have that extra space over here that I need for the 1, which might cause us a problem.
I see. Okay. Um, okay. Okay. Oh, that's, I don't know. I just don't understand this one.
So we can try another one. So we can try another one to see if that'll be.
Yes.
Let's take a look. Second down returns the result of decreasing the second digit of a positive number by 1. Okay, we can try this one if you like.
Is it like simple? Oh, okay. Sorry, I just said before.
What happened?
Yes, nothing. It's just like can you give an example of like basic recursion first, then we can go over this one?
Yeah, I can give you an example of a basic recursion one. Think of factorial.
Okay.
Factorial returns an integer, takes an integer, and all it does is we say if n equals 0 or n equals 1, we return 1. If not, we return n times factorial of n minus 1. And so that's essentially just how it is. You do n times n minus 1 times n minus 2 times n minus 3, dot, 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 until you get to 1, really. And that's the mathematical way of doing it. This is the simplest version of recursion that we were taught in 111. I'm trying to see if there's anything else. Nothing else off the top of my head, but if you know that for recursion, then you should be fine. You have a good foundation, and you'd be able to work your way up with different types of problems like this one. So this one we see it says C out, so we automatically know that we have to return an integer. because of that C out. And it's called second down. And we return an integer. Taken an integer, excuse me. And so we say, if, and remember, it said it lowers the second integer down. So we want to check if it's less than 100. If it is, before we subtract 1, we first want to check if it's a single digit number, because it still could be a single digit number. And if x mod a mod 10 equals 0, sorry, not if it's a single digit, if it is 0, which I mean, we could do it as 2 separate ones. Yeah, but this is fine. Then just return a, because we don't want to get negative numbers. Then what we do is, if not, then we'll just say else a minus 1. We let the computer calculate it for us. Okay, that's only if it's 2 digits. If it's not 2 digits, then we have to somehow get it to 2 digits, but while preserving all the other digits. So we do the recursive call, second down. And we want to say a divided by 10. And again, we want to have that one space for that last digit until we go to the second to last digit. Okay. And that's about it for recursion. Yes. Somebody has
For
a hand up?
the base case, you wrote else a minus 1. Why wouldn't it be else return a minus 1?
Give me 1 second. Let me see. It should be return a minus 1. You're right.
Okay. Oh, you wrote times 10. Okay, my bad.
This one. Okay. No, you're right about that one. Okay. Perfect.
Hey, quick question. So, one of the previous problems for arrays, you put the array, you put C minus 1, and that's to find the last index of that array.
Correct. Because C
Yeah.
minus 1 is the capacity minus 1. And so if the capacity is 5, C minus 1 is 4. So it gets us 4.
Okay, I see. So if I want to find a specific index within it, let's say like the second to last one, I could put C minus 2, and
Exactly.
then so on and so
You
on.
do the second to last one.
Got it. Thank you.
Does anybody else have any other questions? Yeah.
Since the last or not the last review, because I think you did another final review, but the exam 2 review, did CS111 as a class learn anything new?
I think they learned files, command lines. Since the last review, I think they did files, command lines. Let's see what else. String functions and patterns you did, short answer questions you did, short answer you did. Yeah, so just command line arguments, string functions, and files.
Is there a question that would have all 3 of those?
There are 3 different questions.
Can we do one of those?
Sure, which one do you, I mean, I think I did all 3, but I can do
Oh,
another one if you want.
oopsies. I came late.
No worries, I can do another one if you'd like. Do you want command lines,
what?
strings?
Oh, there's no question that has like all of them. Okay.
No, not one question that has all three of them. He has three different questions, about one for each.
Can you give an example of what command lines is, just in case like I already know a little bit about it?
Yeah, let me actually give you a screenshot of it. And then you might see that you know it or not. Give me one sec. Yeah, this is an example of some command line arguments. I'm putting it in the chat now. Okay, it didn't send. Let me try it again.
Short answer questions. They're like the homework problem, right?
I don't know. He didn't show me your guys' test.
Oh, okay.
Okay, this is what the command line argument looks like. Yeah, I put it in the chat just right now. I could go over the
You
specific.
could go over a command lines question.
You want me to?
Yeah.
No problem. So let's do it. So I'm gonna actually do the one that's in the chat. So we have line A. It's a for loop. And we see out words sub I. Now, just so everybody knows, it's string words sub 4, and it says n easy question.
Oh, okay.
And really all this prints out is an easy
An
question.
easy question. Okay.
But no space in between them.
Really? But the quotation marks.
Oh, no, they do have a space. Sorry, I didn't put the space. You're right. There's a space here. Okay, an easy question. Now the second one for B, we use a for loop as well. The only difference is we print out words sub I. Now remember, strings are arrays of characters. That's all they are. So
Oh, wait. Before you tell me the answer, can I like take a
yeah, go
guess at
for it.
it?
You tell me the answer.
So would it be okay, wait, 0 would be the first one. So would it be A, like capital A,
Good.
and then 1 so would that be lowercase a, and then
Uh-huh.
2 that'd be lowercase e.
Exactly. So it'd be A capital, A lowercase, and then E.
Okay, fine.
So now we can see. Excellent.
What's the star argv on the first line?
That means the character the character array of arguments. So we're gonna go over that because that actually comes up right now, where it says words sub 3 will equal arg v sub 1. And so what that means is our arguments are up top. These are what we consider arguments. And they are 3 arguments broken down into 0, 1, 2. They are held in an array called argv. Argc means how many arguments we have. In this case, it's 3. Right? It's the capacity. The C means capacity.
I see. Would argc be different if we had 4 arguments?
Yeah, then argc would equal 4, and then there would have to be a 4th argument in argv.
Oh, so no matter what, we write argc.
Correct.
Okay. And then we have to write character times argv.
Well, you don't have to write that. He'll write that for you on the test. You'll have to just know what argv is, because if it says this, argv sub 1, that means ABC. And over here, this is word sub 3, it now becomes ABC. Then if he says
Gotcha.
C out for C, he says C out, words sub 3.
It'd be ABC.
Exactly.
Well, okay. ABC.
And then if he says plus plus words 0, 0, first we figure out what words 0, 0 is, and that's A. And then plus plus means we add 1 to it, so it really becomes B. Okay? We can do that with
Okay.
letters, by the way.
That's with the ACII chart.
ASCII table, yep.
Okay.
And then they say C out argc, and then that would just be the number of arguments we have, which we said above was 3.
Okay.
We don't
Yeah.
use the index for that because
We don't use the what? Sorry?
the index because from above you put 0, 1, 2, so we just count the straight numbers of arguments.
Correct. And that's it's just like in an array. An array you have, oh, actually here's an array right here. The capacity is 4, but the indices are 0, 1, 2, 3. So if I say here, let me put on the side, words dot length or words dot size, both of these would equal 4. Okay. Because regardless, it's just asking us how many arguments there are, not where the argument is located.
I see. Thank you.
No problem. All right, are there any final last questions before we end off? I also am gonna put
What was the other stuff? I
I'll
think
put
I
that in
touched
the chat for you. Files and we just did command lines, so string functions.
Could we do string functions? I'll be quick.
So here's an example of a string function. Dot size and dot length. These are the other ones you probably should know. There's dot find and dot substring. Those are the other 2 you should definitely know. Let me see if I can give you guys a review sheet. Yeah, here. I'll put it in the chat. It has the answers on it also. So feel free to use that and you'll be able to understand more with it.
Okay.
Give me 1 second. Make sure everything. Yep. Okay. Perfect. if you guys are able to please fill out just the feedback form so we can do this for next year when you guys take 211 or 212 or both, that would be really, really helpful. I can stop sharing my screen. If anybody has any last minute questions, feel free to stay on. I'd be more than happy to answer it.
I'm because like I wanted to find the string function questions, but then it just like when I click on the file that he gave us, it shows only the output, arguments, and signature, program design, and recursion. So
I'm not sure why.
mhm.
Yeah, I'm not sure why. I would ask him about that.
Yeah, I'm just sorry. I'm sorry.
Yeah. Okay, so if nobody else has a question, Sulaiman, you can stop. Actually, I think I can stop recording.